So it's taking your voices and everything in the video at this time. We are now going to review a little bit on the functions. So this first function on the first worksheet that we have worked so far, first one is a square root function. The name is also mentioned over here. Square root function is a function which is plotted like this over here. And let me highlight it somehow. Like this is the function that we have plotted here, square root function. What are the key features? The key features for this, its domain is always all positive real numbers. Okay, it doesn't exist on this left-hand side, it just exists on the right-hand side. So its domain is all positive real numbers. Its range is again all positive real numbers. We didn't do one thing over here last time. We did not put the arrows, and I told you that the arrows should always be considered that the arrows are there. Where? If I will have to highlight an arrow in this function, where will that be done? I'm considering that this function is always continuously going up till the positive infinity. So I just added an arrow over there. Again, the function name is square root function. Then, what's the second function? The second function over here is the absolute value function, and we do remember the absolute value function also. It keeps on going to the positive infinities, upwards, right and left also, it keeps on going to the positive infinities, and we did name it the absolute function. Second function is called absolute function. Then the third one, I didn't put the name over there last time. Let's add the name, but before that, again, keep in mind, arrows will keep on going like that. This function, we call it a rational function. So let me name it. It's a rational function. A rational function. Any function when it's in fraction and the variable is in the denominator is a rational function. Keep it in mind. This is a rational function. So let's highlight this also. We have worked on the domain and ranges. We will be discussing it a little bit more because today's main topic is different notations for the functions for domain and range. We will use 4 different notations for the domain and range, and the worksheet that we have at this time is going to be useful. Then the next function here is called exponential function. Exponential function. Exponential function like that. For this as well, arrows are going there and on the left hand side also. For this exponential function, the x-axis here is an asymptote. This is an asymptote. Okay. How far is it going to the left side? Because an arrow, because of that arrow, it's going up till infinity to the left hand side. I can mention the domain from negative infinity up till positive infinity. And the range for this one, because it doesn't touch the x-axis, range is bigger than 0, but it keeps on going up to positive infinity on the upper side. So the minimum is greater than 0 and the max is positive infinity. Let's keep on going. Logarithmic function. The next one here is a logarithmic function. Logarithmic function. What I can do at this time is, okay, exponential function. This is the name of the exponential function. Next was the logarithmic function that I did not mention last time. We didn't discuss it in full, but let's now do it. I told you last time also that you can always plot these functions in decimals. So let's do it quickly. I will bring it here, the logarithmic function on decimals. Do it together. If you have this worksheet available with you at this time also, that will be a good choice to work along with me on this worksheet as well as on the decimals. So let's bring it up here. Decimals. In decimals, what will I do? In the graphic calculator, the logarithmic function log of x. That's how the function is plotted. Where do you see it's continuously going downwards? That will mention the domain. The range, downwards and upwards is the range. Left and right is going to be the domain. So this is the plot for the function. I will try to plot the same thing over here. Downwards to positive infinity, then it touches the x-axis and then keep on going to the right. Here, it's an arrow to the right, an arrow to the bottom. And with these arrows, if I will mention the domain now, how do we mention the domain? The domain is based on the x. And x less than, we will mention the leftmost here. Leftmost, how far do you think it's going towards the left side? How can I determine from the graph? It has something like from here and it keeps on going to the right side. The green color or this arrow is showing me the existence of the curve along x-axis, but I can definitely see that it's not touching the y-axis at all. There is an empty circle, and that tells me for the domain side, it's never getting equal to the 0. So it's greater than 0. X is greater than 0. That's what I will mention. And how far is it going to the right side? Infinity, positive infinity. Okay. Positive infinity. Now let me tell you another notation that we can easily say the same thing using interval notation. And that's what we will discuss further in detail. There are two things that we can always include in interval notation: parentheses and the square brackets. If a number is inclusive, 0 is not inclusive over here. Why? Because it's an open circle, it's not a closed circle. So for this one, 0 is not inclusive. I will use the parentheses here. That's how I will mention the same thing. It's the same thing. If you will mention the domain like this or like this, both are exactly same, no difference at all. I'm not using x anymore, but if the interval is mentioned like this, we have the same two concepts for domain and range. What is the range here? For this logarithmic function, the range depends upon how far is it going to the negative infinity side, like minimum point. How far is it going down? The arrow tells me up till negative infinity. It will always keep going down up till infinity, forever. Negative infinity, and remember we will need the y and the less than signs on both sides. And that's where the range is determined. Again, whenever we have an infinity, we will just be using the parentheses. We will not be using the square brackets. Make sense? Something that we have done in the past. Now, quick revision. So we have logarithmic functions, exponentials, rationals, square root, and absolute value functions. These are the names of the functions. Now, I will take you to the to another example here. Remember this one? This plot where we had one open circle here on the top, where the point was +1 and 2. And we had a closed circle here. And we have already mentioned the domain and the range. To give you an example, I will bring in here, how will you mention the same domain and range in another notation? What do I mean by another notation? I will use the interval notation now over here. So if I will mention this domain, you see, -4 is inclusive. Whenever something is inclusive, we will use the square brackets. This is a square bracket. With the square bracket, I will put here a -4. And here, I will put a 1, but 1 is not inclusive. I will put the parentheses, not the square bracket. Square bracket is used whenever a number or a limit is inclusive. And I have used here the parentheses on the right hand side with the 1 because 1 is not inclusive. Same will go with the range also. Can you tell me, if I'm putting here the -7 and a 2 with a comma, what should I put with the -7? A square bracket or the parentheses? What will determine if it should be a square bracket or a parentheses with the -7? Jacob? A bracket. Bracket? Whenever you see this line, yes, that's a bracket. Good one. Here we have a -7 with the equality line also. So that's a square bracket. We call this square bracket. What about the 2? Parentheses. Parentheses, good, because it doesn't have an equality line, so it will be the parentheses. An example from the second worksheet that we have already done. Now let's practice the same thing again and again in the worksheet that I've given you here. First of all, which function, we will determine which function is discrete here and which function is continuous. Easy thing. Look at that. This first function, it's continuous. Is it a line or the dots on the plot? What do you see? If the function is continuous, you will not see any break. I just tried to highlight the whole function in blue. Do we see any break in that function anywhere? Anywhere do we see any break? The function is not broken at all. Any such thing, I will claim that it is continuous. So I'm going to highlight the continuous. Okay. Second one, let's try to do this over here also. If I will plot the second function, what do you think? Is it continuous or a discrete function? Any breaks? Again, is there any break or pause, or you see the dots or the straight line? Not straight, like curved line or straight line. So this will also be continuous. It's not discrete. When will it be discrete? Discrete can be something like this, where you will see the pauses and then the function continues. Like the red one, the red lines over here, this can be a function also, but this function will not be continuous. The red one will be discrete. I'm just leaving it there, okay? What about this one? Is it continuous line or the dots? Dots. So it has the breaks. It doesn't continue all the way from 2 points, within 2 points. So this function is discrete. Difficult or easy?
What's the first one?
First one, continuous. First one is also continuous because it doesn't block, it doesn't pause, it doesn't break. Now, how many notations do you see now? Here. we see here 4 different notations. Which one have you learned already? This is the one inequality notation that you have already learned. Inequality notation. If you have learned that already, can you tell me what should be the domain and the range for this function? What I will do, I will put a line in the middle, and that's where we will differentiate the domain and the range. I will be mentioning the domain for all over the left side, and I will mention the ranges in all different rotations on the right hand side. Make sense? Domain for the first one, verbal description. But before that, let's do one thing. The thing that we know already. We know that the inequality notation, how to write it. We have learned that for the domain inequalities, we will always use the x is less than on both sides. And then for the range, we will always put here y less than on both sides. And then we need to determine how far the function is going to the left and to the right for domain. So looking at this arrow, do you think that the function will ever stop going to the left side? I'm pointing out this red highlighted arrow. Do you think it will ever stop going to the right hand side? And let me use the green color to claim the existence of the curve along the x-axis. Do you agree with this? That on the left hand side, the function keeps on going, and the right hand side also, function keeps on going. What's the domain then? Starts from negative infinity, because it goes all the way to the left, and the right also, it's an arrow, so positive infinity, that's going to be the domain. Okay? Do I need to put the equality sign here with the inequality if it's an infinity? Never. We will never do that. For the infinity case, it will never be an equal sign with the inequality. Then, what about the range? What's the minimum point for the curve? Now let's try to figure out what is the existence of the curve along the y-axis. Do you think this purple line is correctly reflecting the existence of curve along y-axis? Is this not the minimum point at the bottom for the curve? I have filled the circle here because it's a continuous curve without any break. So the circle should be filled over, right? Then, what's the minimum limit for the y? We can count it, definitely. If I will start putting the dots over there from the origin, and where is the origin? Starting from here, 1, 2, 3, 4, and 5. Is it right? So negative 5. No, am I wrong? You're right. 0. Starts from 0, 1, 2, 3, 4, negative 4. Here, the coordinate is negative 4. So I can mention it as 0 and a negative 4. Thank you, Evelyn. 0 to negative 4 is going to be the coordinate for the minimum point. What are we looking at? The range or the domain?
The range.
Range. So what's the minimum point for the range? Good. Negative 4 is the minimum point, and we are still working on the inequalities notation. We are almost done. Once you have figured out the domain and range, it's just a matter of using different verbs. So from negative 4 up till where on the upper side? How far is it going up?
0.
Arrows are telling me how far is it going up. And this arrow in the middle, it's also telling me how far is it going up? Positive infinity. Whatever. That's the positive infinity. Now, I will bring in the other notations. Verbal description. When I will put the verbal description for the domain for this same function, From negative infinity to positive infinity, whenever you have this, you will mention all real numbers. That's the domain. All real numbers. If there is any break or there is a starting point, then we will say greater than or less than or greater than or equal to that specific number. Verbal notation is easy. Then for the range, does range contain all real numbers or it has a starting point or an ending point? What do you think? Range does start from -4, and I should definitely put the -4 with an equality sign over there. How will I mention the range? Let me show you, let me tell you, so that you can keep it in mind, and next time you should be able to do it yourself. It's a concept. Starts from -4, goes all the way up till positive infinity. So I will say all real numbers, but not just all real numbers. There is a limit also. There is a starting point. I will have to bring in that starting point saying greater than, greater, and equal, greater and equal to -4. That's how I will mention the range. It's almost here, appearing. It's a little bit of gap, but trust me, it's saying all real numbers greater than equal to -4. Does that make sense? Wording. You will say the same thing that you have mentioned in the inequalities form. You will say the same thing in the wording. That's the verbal notation. Now I will use the interval, a set notation. A set notation, easy thing. Let me tell you one thing, an easy way of writing the set notation. Just use the curly brackets. Write down there x. Now be careful. I'm using a specific term here, specific thing that I will claim. I'm using the curly brackets for the domain, and then I will bring in here because domain is always related to x. So we should write here an x. And after the x, I will mention the two dots. Do you remember what do we call these two dots? In punctuation, what do you call that? What do we call these two dots? One has appeared, the second is still in the go ahead. Now, what do we call these two dots in punctuation? English punctuation, simply. Is it a full stop, a colon, or a semicolon, or an apostrophe? It's not a full stop. This is a colon. This is a colon. Not a semicolon, it's a colon. And for this colon, we will read this colon in math. We will read this thing as such that. How will we read it? We will read it as such that. So x such that x. I'm now bringing two things more. Look at this. I'm bringing this notation also, which is something like a semicircle, and then in between there is a line. This is read in maths. You can call this as belongs to. X such that x belongs to what? This R. Don't just write it as an R. I will suggest you to differentiate it from the single R by adding a line to the R's existing straight line. This will tell us it's not a simple R, it's a real number. A set of real numbers. So X is all real numbers. That's what we have mentioned in the wording also. All real numbers. So saying the same thing in set builder notation, we will use this notation. X such that X belongs to all real numbers. That's how we will mention the set builder notation. Is it difficult? We have an easy way of writing it. So do you want to go for the easy way in the set builder notation? You know what will I do? The same thing that I have mentioned in the inequalities, I will put that same thing down over there. Look at this. How will I do it? Let me try to create some space here. I will try to make it a little bit smaller. Okay. Now I will bring in the other way of writing the set builder notation. And what is that? I will start with the curly brackets. I will again mention the X. I will again mention the two dots, which is read as such that. And then I will bring in the same thing which we mentioned in the inequalities notation. Nothing changed. From negative infinity up till positive infinity. And then we will close the curly brackets. That's it. So set builder notation is really easy. What we will do, we will bring in this all inequality notation from here, and we will put it over here. Instead of just saying X belongs to the real numbers, we will mention the same thing over there. Let's wait for it to appear over there. Here. Oh, it's taking a lot of time. Now it's there. So X such that X is this. And where did I get this inequalities from? I got this from the inequalities notation. That's how you can also mention the whole thing in the set builder notation. Now, range. How will I mention the range in the set builder notation? Let's make our life easier. Same thing that I have mentioned over there. I will bring it over here in the Y such that, again, when I'm saying such that, in fact, I will be writing over there the column Y such that, and then I will bring in the same thing that we have in the inequalities notation. That's the same thing that I will mention over here. -4 less than or equal to Y less than or equal to infinity, the positive infinity. That's how I will write it. 3 notations done. 4th notation, I told you, we will be using in the interval notation 2 types of brackets only, parentheses or the square brackets. Parentheses or the square brackets. So for the first one, because it's from negative infinity to positive infinity, now I'm writing it here from negative infinity to positive infinity. That's the way I will write the domain. And why am I putting the parentheses? Because we never put the equality sign with the infinite. So we never use the square brackets with the infinity signs. Then for the range, again, the limits, the minimum and the maximum with a comma, that's what I will do. In case of the range, now because 4 is inclusive, 4 here does have a line of equality. So that should be square bracket or a parenthesis. Bracket or the parenthesis. Okay. Whenever we have a line, we will use the bracket. We will use the bracket. And whenever we don't have the line with the inequality here, that will just be the parenthesis. Make sense? Okay. This was the 4 different notations for the domain and range.